do get continuity. You do get continuity of insulation there. So it interlocks together. You can see what a great finish you have. Also, it comes with a range of accessories. So if there's anybody from building control on here, just make your clients aware, if they are using cavity therm, that these are available. One of the beauties about the system is it comes with, or you can order pre-formed corners, both internal and external. You can see there at the top. So whereas normally you would cut and miter the boards, you actually get no gaps whatsoever, which is great for the photographic evidence that is required now, and really does help with that process. Comes with starter panels, backing pieces for meter boxes, insulated hockey stick pieces for the cables that go into the meter box, and also a cavity tray channel that you can see there as well. So all the things that are difficult to insulate or sometimes just get forgotten about, we've kind of thought about. And in terms of cost, your clients don't pay any more for these accessories. It's all the same square meter price. So I would encourage people to actually use them, just really closing that performance gap that the new changes in the regs are trying to address. So let's have a look at Part L 2021 now. So changed on the 15th of June last year, and it was a 31% reduction in CO2 over the old Part L 2013. And we've now got the following metrics in SAP to get compliance. So there's a new metric called a primary energy target, and that's measured in kilowatt hours. So that's a brand new metric energy assessors are having to get themselves familiar with and see what it takes to get a pass with that. You've got a CO2 emission target still, which is obviously improved. You have the fabric energy efficiency target, which is staying with us. In the consultation, government did suggest removing that, but after a backlash from industry decided to keep it, which was the right thing to do, because I'm sure everybody on the call knows that the fabric is the first port of call for any low energy design and reduces the demand on the heating system in the first place. You've got new minimum standards for fabric and fixed building services as well. So these are the new minimum standards. So these are the worst allowable U values that are available. So if any U values are worse than this, you'll fail an energy assessment. If you followed these, you probably wouldn't pass either. They are going to have to be significantly better than this. But what it does do is allow a little bit of flexibility in the design. So, for example, if you take the external wall, under the old Part L 2013, the worst allowable U value was 0.3. It's now been reduced to 0.26. So as an example of that, if you have dormer cheeks, which are measured and input into SAP as external walls, potentially you could have that very small area with a U value of 0.26 or 0.25 or whatever, but have your actual external walls to 0.18, which is the notional dwelling U value for an external wall. So it's a very small area, wouldn't make that much difference, but allows for that flexibility, because as you know, with dormer cheeks, you don't want them to be too thick. You want to maximise on the space in that particular area. So this is the new notional dwelling. So typically, if a building designer followed this recipe, it's deemed that you would pass an energy assessment. So what we have here is your thermal bridging Y value is at 0.05. So that hasn't changed from the old notional. Air tightness is 5. Obviously, the better the air tightness when it comes to the as-built, the better results you're going to get. That goes towards the fabric. It's now, this time around, they're still based on a mains gas boiler. So if the dwelling is having a mains gas boiler, in order to get a pass on the energy assessment, you're probably going to have a wastewater heat recovery and also PV panels. And in terms of your U values, we're looking at external walls of 0.18, floors at 0.13, and roofs at 0.11, and your windows at 1.2. But obviously you don't have to install gas boilers, and if you don't install a gas boiler, the likelihood is you're not going to need a wastewater heat recovery or the PV. However, a lot of clients might want PV just so they've got their own on-site generation of electricity these days. So let's just take a look at thermal bridging. So thermal bridging has changed under the new Part L. The approved values in table K1 have been removed, leaving default values. And with anything that's default, they're very poor values. So using them alone and relying upon them alone these days is going to be very, very difficult to get an energy assessment to pass. So what the energy assessors are having to use these days is independently assessed psi values. So at Unilin Insulation, we do have a suite of psi values and certificates available, which are based on the standard details within the accredited construction details. So if anybody on the call would like those, please make a note of my contact details and I'll happily send you all of those over. Or if you want, just contact me on a project by project basis and I'll send you the relevant certificates if you like. So options is to get them from which have been calculated by a suitably competent person following BR 497. So I have a guy in the office called Mark McGuinness, who's my suitably competent person who can thermally model junctions. And he actually created all our certificates. You can also go to a non-government database, which have been independently assessed, such as the LABC or the BRE. And in fact, our details are on the BRE database also. You've got the default values, obviously, which are still there. But again, using them alone is going to be very, very difficult to get them to pass. And then you also have the default Y value as an option, which under the old Part L 2013 used to be 0.15, and they've made that even worse now. So it's 0.2. So default, pretty much you won't get a pass. So a lot more attention to the detailing is required now. And again, here's one of our certificates here. This is a floor-to-wall junction, so an E5 junction with cavity therm and high floor in the floor. And here you can see, again, just cavity therm. So we have them for a range of different blocks and all the different thicknesses of cavity therm that are available. We actually have an easy to look at kind of spreadsheet with all of the psi values on, if anybody wants that, as well as the certificates. And here you can see all the junctions that are from table K1. What the default psi value is, and you can see there with a block thermal conductivity of 0.19, you can actually see how low our psi values are. And for anybody that hasn't used them in an energy assessment on a project, they do perform very, very well. So, Future Home Standard. We've got a very quick succession of changes to our building regulations, and just as we've had Part L 21, and it's now that we're kind of starting to work on new projects for compliance. We've got another change looming and imminent. So there's a consultation due out again this year to the Future Home Standard for 2025, potentially being published in towards the end of next year and implemented in 2025. So not too far away. And the Future Home Standard is 75 to 80% less emissions over the old Part L 2013. And it's deemed that no retrofit will be necessary as the electricity grid decarbonises. It's expected that this will be achieved through very high fabric standards and low carbon heating systems. So subject to the consultation, we're looking at no gas, no oil or LPG heating systems to be permitted any longer. There will be a reduced primary energy target and also obviously a reduction in CO2, a reduced fabric energy target also, and a review of the minimum standards for fabric and fixed building services. So the government have published an indicative future homes standard specification, this is what that looks like. So floors, we're looking at a U value of 0.11. External walls, we're looking at a U value of 0.15. So if you're looking at a full fill PIR in that circumstance, you'll be looking at a 125 mil cavity. So not having to extend them all the way to 150. Obviously, you gain more internal space or potentially more plots on a piece of land. And obviously, you don't really want to extend cavities beyond 150 for structural reasons as well, for the structural engineers that are on this call today. The other big change here is your windows. So with a 0.8 U value, you're looking at triple glazed units, heating appliance, low carbon heating systems such as your heat pump, your emitters, low temperature heating emitters, obviously for your heat pumps there, they run at much lower operating temperatures. And at this point with air source heat pumps, it is more important than ever to insulate these dwellings as well as possible. And no PV within this recipe, but obviously the recipe itself is subject to change following the consultation. Now, we have been involved in a project in Birmingham, which is going to the government as part of the consultation to the Future Home Standard. We worked in collaboration with Birmingham City University and Midland Heart Housing Associations. And I believe the project started about 2 years ago, and it was designed to be 80% less CO2 emissions over the old Part L 2013, so designed to the Future Home Standard. And they did this recipe slightly different. So they found it quite difficult to find triple glazed windows. They were expensive, they were heavy. And because it's a housing association, it's their responsibility to replace the units when they need replacing further down the line. So what they decided to do was go for 1.2 double glazed windows because they were easier to get hold of, wouldn't hold their build program up either, and compensate for that in the actual external wall. So they opted for a 0.13 U value, and we still managed to get obviously 80% reduction in CO2. If anybody wants to know the various different specifications that were used over the 12 dwellings on the project, again, I can share that with you. They looked at slightly different heating systems, some different air tightnesses, and the occupants are living in it now. So it's almost like a living lab. It's been metered, monitored, fire tested, thermal imagery, everything is being thrown at it, and all this information is going back to government. So an actual live project where they can see the actual results before they implement the changes to the building regulations. So it is quite interesting. So what we have on the screen now is, if anybody on the call remembers, back in 2010, we were supposed to be zero carbon for our new homes by 2016, and it didn't happen for various different reasons. We had devolved parliaments, changes in government, Brexit, lots of excuses, but anyway, it didn't happen. So you've got the original zero carbon homes notional, which they published at the time. You've got the old Part L 2013 that we were working to up until middle of last year. You've got the new Part L 21, which we're now working to, and the indicative Future Homes Standard specification. So at a glance, you can see where all the changes are coming in. So floors from a 0.13 now down to a 0.11, you're typically looking at a 25 mil increment of PIR or phenolic insulation for your floors. External walls from 0.18 down to a 0.15, again, about a 25 mil increment. Your roof remains the same, 0.11. Windows, obviously, triple glazing come 2025. Air tightness, gas boiler at the minute, but obviously you don't have to install a gas boiler. And if you don't, and you go straight for an air source heat pump or something similar, then you're almost kind of future-proofing your design. So it would make sense to go for that. Where you have got a gas boiler now, you are looking around about 40% of ground floor area of PV with that wastewater heat recovery as well. So no metrics for embodied carbon, so climate change is unaddressed at the moment. So let's have a look at embodied carbon. So London, you've got the GLA, have been conducting life cycle assessments for some time now, dependent on the size of the project, etc. Various other cities and local authorities have set their own targets to be zero carbon ahead of 2050. So looking to calculate embodied carbon also. And certainly I hear a lot more talk about it now. Government have launched an inquiry to look into including it as part of our legislation in our building regulations. And we are kind of expecting this to come in at some point in the future. And that is why at Unilin Insulation, we've produced the Eco360 range in readiness for it, because of those sustainability credentials with it, which we are trying to improve constantly. It's going to have lower embodied carbon scores than our traditional range of products as well. So that's one of the reasons we've brought that out. So let's have a look at the RIBA Climate Challenge. So basically 2 days after the UK government passed a law to end its contribution to be net zero by 2050, they brought out the RIBA Climate Challenge. They basically don't believe government are acting fast enough to tackle climate change. And they say that RIBA chartered architects must act now ahead of any future regulation. So what they've actually done is set targets within the challenge. There's a target for operational energy, which is obviously legislated for, but they're looking to improve on that. They've set a target for embodied carbon, currently not legislated for, but it's coming, and a target for potable water. So in terms of operational energy, this is based on a domestic dwelling, by the way. They have set targets for other building types, such as schools, etc. Operational energy, business as usual, would be 120 kilowatt hours per metre square per year. They're looking to get that below 35. Embodied carbon, business as usual, would be 1,200 kilograms of CO2 of energy per metre square. And the target for a domestic dwelling is to get that below 625. Then you've got a target for potable water. So business as usual would be 125 litres per day. And the target is to get that below 75. And in actual fact, we're using more potable water than ever before now. On average, we're using 141 litres per day. So it seems like an easy target, an easy challenge, but it's actually not as easy as it sounds. So in terms of the embodied carbon here for the domestic dwelling, we are going to cover that in the XCO2 report later on. So remember that target of 625. So with your operational energy, obviously it's very, very difficult to know and to guess what that will be. Everybody uses their homes differently. SAP will give you a guide on what the operational energy will be. But without having confirmed energy bills or metering systems in place, which you're not going to have until the dwelling is built and lived in, they say you should aim for 15 to 20 kilowatt hours per metre square for your space heating demand. So that is similar to passive levels. So let's have a little bit of a deeper look at embodied carbon. So the term embodied energy and embodied carbon are commonly referred to as the sum impact of all greenhouse gas emissions to a material during its life cycle. There's two terms. There's embodied carbon, and embodied carbon is the sum of CO2 associated with a product. And you will have also probably heard of embodied energy. And embodied energy is the sum of energy in kilowatt hours to produce a product or a service. So they are different things. So as an example of embodied energy, we have a data centre here that uses 481,000 kilowatt hours of electricity to power it. That's embodied energy. The consumption demand remains constant regardless of the energy source. However, the carbon content of that energy source determines the carbon footprint. So if it's powered by wind, that will be low on embodied carbon. And if it's powered by coal, that will be high on embodied carbon. So in terms of embodied carbon, basically what this stems from is sourcing materials, fabricating them into products and systems, transporting them to site and assembling them into a building. And they also include the emissions due to maintenance, repair and replacement, as well as final demolition and disposal. And if you look at that pie chart there on the screen, 51% of carbon emissions actually comes to practical completion. So that's even before the building is operational. So it's a massive amount of carbon, which at some point has to be tackled. So how to work out embodied carbon? This is carried out by doing a life cycle assessment, and this is the methodology for assessing the environmental impacts associated with the stages of the life cycle of a commercial product, process or service. So you'll have heard of cradle to gate. That includes raw material extraction and manufacturing. And then cradle to grave includes that, but also the distribution, use, disposal and recycling. So let's have a look at the RICS methodology. RICS have defined the methodology to calculate a building's embodied carbon by conducting a life cycle assessment. Basically, the embodied calculation requires a building element to be broken down into its components for which embodied carbon factors need to be sourced. The RICS methodology offers guidance on carbon critical elements that are recommended to be assessed. So as an example, we have an external wall here. So you'll have a quantity of blocks, quantity of cavity therm in this instance, quantity of bricks and a quantity of mortar. Each of those components is times by its embodied carbon conversion factor. And then it's times by the amount of blocks, for example. All of these are then added up and you get the embodied carbon of a cavity wall. So it does sound quite simple. So some building materials and products are more carbon intensive than others, and it's advisable not to calculate the absolute total footprint of a project, as many components will have a negligible effect. Typically, it's around about 80% of the overall embodied carbon footprint is actually calculated. All of this is set out within the RICS guidance document. So not only have you got RIBA with their own climate challenge, you may also have heard of LETI, Low Energy Transformation Initiative. This is specifically aimed towards developers, landowners, designers, policymakers and the supply chain, so not just RIBA chartered architects. So LETI have broken their targets into upfront carbon and total embodied carbon. Upfront carbon is from the materials production and construction phases. So that specifically looks at phases A1 to A5. And this looks at the life cycle of the building or infrastructure actually begins to be used. So in contrast to other categories of emissions listed here, these emissions have already been released into the atmosphere before the building is occupied or the infrastructure begins operational. Then you've got the total embodied carbon. So that includes the whole life cycle assessment. And you can see here that band B corresponds to the RIBA target. So for your residential dwelling, you've got that target of 625 there. So environmental product declarations, or otherwise known as EPDs, these are the measure of the environmental impacts of a product through its life cycle. So we have our own EPDs, and what they look at is A1 to A3, which is the product stage, which is the raw material supply and manufacturing. You've got A4 to A5, construction stage, which is transport to site and assembly. B1 to B7 is the use stage, use, maintenance, repair and replacement. Then you have C1 to C4, which is end of life stage, demolition, transport to disposal and disposal. And D, which is the reuse stage, recovery and recycling. So when we're able to recycle our Eco 360 range, which will be soon, we will then get an even better score, because obviously we will be recycling at some point also. So EPDs can be sourced from the manufacturer. They must be independently assessed. When creating a life cycle assessment, an EPD must be available on the software. So we in our office have the one-click software, which is the one that's kind of leading the way in terms of doing life cycle assessments. Where environmental product declarations are not available for the specified product, there are generic databases out there, but again, like anything generic, the scores are not going to be accurate and they're going to be erring on the side of caution. So it is kind of early on in the journey of calculating embodied carbon. So many manufacturers still don't have EPDs. A lot of them are working on them at the moment. So it is kind of a work in progress. So when we are calculating the embodied carbon in an EPD, it's specifically looking at the global warming potential. So it measures the greenhouse gas emissions associated with the manufacture and use of a product or service, sometimes known as the embodied carbon or the carbon footprint. So it's measured over 100 years. So here you can see carbon dioxide at the top there, which is energy combustion biochemical reactions. It looks at all sorts of different things. You've got your hydrofluorocarbon at the bottom there, which just remember that one for later on in the presentation. That looks at refrigerants and industrial gases. Also looks at your ODP, so things that cause damage to our ozone layer. You've got acidification there, which causes acid rain. But the main thing is the global warming potential. So EPDs can be very difficult to interpret, which can lead to incorrect details being used in the embodied carbon calculations. Specified materials must be the same as the database listing. So we have 4 production facilities in the UK. Just make sure that the EPD you're using is the right one. So the products supplied to site did come from Chesterfield or did come from Ross and Y, because they're going to differ, because obviously the manufacturing facilities are different. EPD scores are not linear and varying thicknesses cannot be readily calculated. So an example of that, our EPDs are based on 100 ml of product, which is pretty standard and widely used on projects. Another manufacturer of PIR and phenolic insulation bases theirs on either 56 ml or 66 ml. It's not a manufactured project, but if you were to look at an EPD and compare them and weren't unsure how to read them, their embodied carbon score would look better than ours, but you might not realise that it's based on a different thickness. Now, if you did notice that and wanted to rectify it, what you can't do is prorata it. So you can't take their score, divide it by 56 or 66 and times it by 100 and think you're getting like for like. It doesn't quite work for that. EPDs are also valid for 5 years, so just make sure that they're still in date, basically. The calculation of embodied carbon is at the very early stages of development, and as it becomes more standardised and accepted by the wider industry, we expect that full and accurate material properties will become more readily available. So they can be very difficult to interpret. They do contain a significant amount of data. So an example of this, we have an EPD here for some windows from Winster Joinery, another one here for some paint from Johnson's. So we're looking at A1 to A3, which is the manufacturing stage. So the windows is at 1.60 plus O2 and the paint is at 1.64 minus O1. So at a glance, they look very, very similar. However, because the windows is 160 plus O2, the decimal point moves twice to the right, and the paint is minus O1, the decimal point moves once to the left. So now what you're seeing is the actual embodied carbon impact. The reason they do that, if anybody's wondering, is because when you're calculating the embodied carbon, the global warming, etc., it comes out to so many decimal points, and this is just the easier way of displaying the data, but it can be very confusing. We have a guy in our technical office called Mark Walsh, who's a member of the UK Green Building Council, and he's very, very knowledgeable on the subject. So if anybody wants to know more, has a project, etc., anything to do with embodied carbon calculations, please do get in touch and we can help you navigate that. So we actually commissioned an independent assessment to assess the embodied carbon and to meet the targets that RIBA and LETI have set out using traditional masonry construction. So we used a London-based multidisciplinary group called the XCO2, and they have backgrounds in engineering, architecture and environmental science. We looked at different dwelling types, so we have detached houses, semi-detached, mid-terraces and apartments. We followed the following standards and used the guidance within the RICS information paper. We had an independent quantity surveyor assess the quantities of materials that were required. And as per both LETI and RIBA, we omitted the landscaping and pavements. We used the one-click software, which you can see on the screen in front of you, which we also have in our technical office as well. And these are the different dwelling types. So the quantities you see there is the internal square meterage. Now, this is important to quantify because when you're calculating the embodied carbon, you work out the total of the embodied carbon and divide it by the internal floor square meterage, and that gets you the total. So that's why that is important. So what we did is we had a baseline specification with an air source heat pump. The baseline specification had some generic EPDs. It had a standard air source heat pump and also standard concrete foundations. In step 2, we had an improved specification, so improved EPDs. So we used our own environmental product declarations with our insulation, which was an improvement over generic EPDs. We had an improvement in the concrete and we had an improvement in the air source heat pump. A couple of other tweaks as well. And then in step 2, with the improved recipe, we also looked at different heating systems. So we'd got the air source heat pump. We then looked at MVHR and passive heating and electric panel heaters, so we could compare the three heating systems. So that was the improved spec and the baseline spec you can see in front of you there. Here you have the results of the detached house with the baseline specification. So baseline specification with an air source heat pump. You can see your A1 to A3, which is the product stage, total embodied carbon at the bottom, 54,000 plus. A4, A5, B1, B2, B3 and B4, and end of life. And then you've got your total there at 584. So even the baseline specification on the detached house came in below that 625 target. So here you can see it in a chart. So detached house again, baseline was below 625. So within the target, within both challenges. Improved specification with the air source heat pump was better again. MVHR and panel heaters better than the air source heat pump. Here you have the semi-detached. So the baseline spec was 660. So that didn't hit the target. However, the improved specifications for each heating system did. Then you have your mid-terrace, and this one struggled because of the small internal floor area. Obviously, if you're dividing it out by the total embodied carbon, you're not going to get such a good score. So you can see your baseline failed, your improved with the air source heat pump didn't hit the target, but your MVHR passive and your panel heaters. And then you have the apartments here. So a couple of other changes. The apartments shared an air source heat pump between each floor, so between 4 dwellings. We replaced the metal stud partitions with timber stud partitions as well. So a few other tweaks on this. Baseline spec didn't pass or meet the target, but the improved specifications did. So just looking at the detail and a little bit more now, we're focusing on the detached house here. So you can see 50% of the total embodied carbon comes from A1 to A3, which is the product. You've got, then you've got A4, A5, B1 there, which is the use phase, which the main cause of that is the refrigerant. A refrigerant that accounts for 7% of the total embodied carbon. And then you've got B4 to B5, which is replacement and refurbishment, which accounts for 19% of total embodied carbon. So what we're going to do now is just look at that 50%, so the product stage. So A1 to A3, which is the manufacturing product stage, which is 50% of the total embodied carbon. 8% of that is the cavity wall insulation. So what you've got to remember with your insulation is it gets installed, sits there and does its job for the lifetime of the building. Air source heat pump in the product stage is 4% of the total embodied carbon in A1 to A3. However, if we look at the air source heat pump through all of the other stages, so A1 to A3 was 4%, B1, which is the use phase, is 7%, and that's mainly because of the refrigerant, if you remember from the slide on the global warming potential. And then B4 to B5 is 8%, that's replacement and refurbished, because obviously it has to be replaced and refurbished over the lifetime of a dwelling. So 19% of the total embodied carbon of a full life cycle assessment is from the air source heat pump, which was quite a surprise to me when I saw the results. Whereas obviously cavity wall insulation just does its job for the lifetime. Just a bit of a look at timber frame and comparing that with traditional masonry. So this is the semi-detached house. This is based on the air source heat pump specification. It's based on a 0.15 U value, so future home standard U value in both scenarios, obviously different build-up with it being a timber frame and a traditional masonry. And the difference was 2.85% in favour of the timber frame. So not a massive difference. You'll find that a lot of manufacturers are trying to make their products more sustainable, so it is very much a moving feast. And in fact, when we carried out this assessment, things will have changed, different EPDs, new EPDs would have been uploaded. So we would get different results now. But in terms of which different heating systems, it would probably fall in the same kind of pattern. But the results in embodied carbon will improve as time goes on. So we're just going to have a look at a few insulation specifications now to finish off. This is your cavity therm. You can see a picture there of the cavity therm system with the preformed corners. As you see, you do get continuity of insulation. So it's a no-brainer really for that photographic evidence that's required now. Of your key junctions, you've got some example U values at the bottom there with different thermal, different block conductivities. So if we're looking at future home standard of 0.15, you can see that a few examples in red there to achieve 0.15 with a 125 mil product in a 125 mil cavity. And obviously the different thicknesses of cavity therm there also achieving very good U values. Cavity Wall Plus, which is one of our many partial fill products. They all do slightly different things, but Cavity Wall Plus, we have our psi values for thermal bridging available. And you can see 100 mil there within a 150 mil cavity, because with a partial fill, obviously you have to leave that 50 mil residual airspace. I'm being told by quite a few energy assessors that 75 mil cavity wall plus partial fill in a 125 mil cavity with our psi values is working very well at the moment. If anybody is looking to use a partial fill as opposed to a full fill. Floor insulation, again, a few different examples with different P/As with the beam and block floor there. The presentation can be shared as well. If anybody wants a copy, just drop me a line. Some examples of ceilings, different U values there and a flat ceiling. We don't do loft insulation at Unilin Insulation, but we do a product called Walk-R. So it's an OSB bonded to PIR. As you can see, it can create a platform. The mechanical things that are up in the loft, or your Christmas tree, or your suitcases, which is more what that I use mine for. Pitched roof obviously depends on the rafter centres and depth, and we'll work that out for you. Just let us know what it is, and we'll tell you the best way to achieve it. If there's any constraints on height, etc., do let us know, and we'll try our best to maximise that for you. And this is a sarking board, so sits on top of the rafters, so eliminates the thermal bridging through the rafters. So you do have to use slightly less of that. So that is the end of the presentation. I can see there's a few questions come in as well, so be great to hear what those are. Please do make a note of the contact details here. You've got my mobile telephone number at the bottom there and email address. If anybody wants any information, SI values, copy of the presentation, a certificate, please do message me. And then you've got the telephone number and email address direct into my technical team, who are very, very helpful. So please do utilise them. So I'll hand back over to Shanika now. Thank you.
Thank you, Donna, for the presentation. As you said, we do have a few questions. So the first one is, how do you assess the condensation risk in your company? I mean, which methods do you use? Dynamic analysis?
Okay, so we've got, it's a bit of a crude calculation actually, but it's within the software that we use to calculate our U-value calc. So it is very basic. So that's if we were asked to do a condensation risk analysis, we'll do it as part of doing a U-value calculation. So we can do that. Certainly, obviously, there's some typical build-ups that we get asked to calculate, which if we think is at risk of condensation, we'll advise that to be the case. My guys are very, very knowledgeable on the subject, but also in terms of retrofit, we have the WFI software in the office, so moisture movement. If anyone's looking at retrofit, again, it's very tricky to do, but again, we do have that capability.
Thank you. Is labour incorporated into your embodiment calculations? For instance, brickwork is very labour intensive, and to my mind, a very inefficient and space-taking method of cladding and modding building.
No, labour wasn't taken into consideration, no.
Okay. Can you please elaborate more why someone wouldn't be able to get a PAS certificate if only meeting the minimum reg figures? Maybe I misunderstood the terminology.
Sorry, could you repeat that?
Yeah, no problem. Can you please elaborate more why someone won't be able to get a PAS certificate if only meeting the minimum REG figures? Maybe I misunderstood the terminology.
Oh, right, I see. So the minimum standards, they have to be significantly better than that, certainly in terms of meeting fabric. They're kind of the worst allowable U values that you can design a building to. That's kind of, as I mentioned, it's mainly for architects when they're putting their designs together. So if they followed those worst allowable U values, you probably wouldn't pass a SAP assessment. You are going to have to follow the notional U values, not the worst allowable U values. I hope that makes sense.
Thank you. Okay, so I'll answer two more, and then if you don't mind, Donna, I'll send you these questions if you can answer them, and I'll send them out. Okay. Have you got the EPDs of your new range of eco products?
Not yet. We're working on them. We do expect them to be significantly better than our standard EPDs. Again, if you drop me a line and you want them, we'll make a note, and as soon as we do get them available, we'll get them sent out to you.
Thank you. And the last question I'll answer, if you are using a full fill PR board, what designs for exposure to wind-driven rain can it be used for?
Okay, so it's all covered in our BBA certificate, but very severe exposure zones. you would use a partial fill generally, obviously, unless an on-site test was carried out. And for severe, you would probably use something like a render coat. But again, it's all in our BBA certificate. So again, I can send that out to you just to clarify.
Thank you. So yeah, I'll send you the questions in a sec.
Okay, thank you.
Thank you. So if there's anyone that has viewed today's session and think it will be benefit to a colleague, we will be uploading the webinar on our YouTube channel, so please share it. If you've got any feedback on our webinars or any sessions you would like to see us cover, any specific topics, regulations, or anything industry related that you think would make a good 40 to 50-minute presentation, please get in touch. With that, I'll wrap up, and thank you again, Donna, for your time, and we'll hopefully see you all next month online.
Thank you.